Hi everyone, part 3 of chemical bonding video, and this one is on covalent bonding. Okay, so let's get into it. So let's look at a molecule that we all know about, H2O, water. Okay, so H, is the valence. This is the valence. I'm only going to draw the valence electrons. Put a cross here. 3, 4, 1, 2, 3, 4, 5, 6. Okay, 2, 4, 6. Yeah, that's right. Right. So the electronic structure here is 1, and here is 2, 6. The valency is 1, and here the valency is 2. The number of atoms here, you have H2. You have 2 atoms here. You have 1 oxygen, and the electrons being shared is 2 here, 2 here. Important thing, this must be the same. Okay, your aim is to make sure that the hydrogen and oxygen share the same number of electrons. So now, when I'm drawing it, O is in the middle, and then I have H over here. Let me put H in a different color, and another H over here. Okay, and we have seen here that each in the hydrogen, it shares 1 electron, right? Because it needs to take in 1 electron, it shares 1 electron. So 1 electron from the hydrogen, each 1 electron from the oxygen, each. So oxygen oxygen has 6 electrons, of which 2 of them are being shared. So you have 4 more. 1, 2, 3, 4. Now let's count the electrons. Hydrogen has 2. This hydrogen over here has 2. The oxygen has 2, 4, 6, 8. Yeah? So that's how you draw covalent bonding. Now let's do another one. Let's do maybe for fluorine. Fluorine, is F2. Alright? And fluorine, the outer shell it has 7 electrons. Right? So each of the atom needs 1 electron. So you draw fluorine. Okay? 7. So it has 3, 4, 5, 6. Shares 1 over here. And then this fluorine is 1, 2, 3, 4, 5, 6. Shares 1 over here. So this fluorine on the left, you have 2, 4, 6, 8. This fluorine here, you have 2, 4, 6, 8. So 8 electrons for each atom, and they are happy. Yeah? Let's look at how you would bond, for example, carbon and oxygen, right? Let's just see. So carbon, that its valence is, let's put carbon, it needs 4 electrons. So just put 4 here. Oxygen needs 2 electrons, so you put 2 here. When you bring it down, you get C2O4, which is same as CO2. So this is carbon dioxide, right? Now, how are you going to do the bonding for carbon dioxide, CO2? You put C in the middle, O at the side, O at the side. Now, you know that oxygen, it needs 2 electrons. Oxygen here needs 2 electrons. 2 electrons. Carbon here needs 4 electrons. So because oxygen needs 2 electrons, it needs to share 2 electrons. So oxygen will give 2 of its electrons. This oxygen will give 2 of its electrons, right? And then it has 4 more. 3, 4, 1, 2, 3, 4. Now the carbon, it has got 4 electrons of its own, right? And because oxygen shared 2 electrons, carbon must give back the same number. So it needs to share 2 here. It needs to share 2 here. So total, it's done because carbon has got only 4 electrons. So checking your electrons, oxygen has got 6 over here. Oxygen has got 6, of its own electrons, yeah? 6 of its own over this side, 6 of its own over this side, and carbon has got 4 of its own. But in total, that means considering everything, you got 2 plus 4, 6, 8. This oxygen on the right, you got 2, 4, 8. The carbon has got 4, 8. So just nice. This is how you would do the bonding for CO2. Okay, so the important thing is, firstly, you have to, the steps, all right, the steps. First thing, what is the formula for the compound? Is it H2O? Is it CO2? What is it, right? Second thing, know how many electrons each atom needs. Okay, how many electrons does each atom need? Because if an atom needs 2 electrons, it means it needs to share 2 electrons. If an atom needs 3 electrons, means it needs to share 3 electrons. Okay, so with this, you should be able to draw all your compounds, all your covalent compounds. I think you should go and practice it. All right. So the next part will be going on to the physical properties of the covalent molecules. Before I actually go on to the physical properties, I want to explain one more point. So just now when we did H2O, it was H2O. Each hydrogen shared 1 electron, right? So you can also write it as this way. Yeah, where you see this is a single bond. That means 1 electron is being shared by each atom. Okay, we did CO2 too, CO2, right? Where we saw that each of the atoms shared 2 electrons. So COO, this is what you call a double bond, right? Because 2 electrons are being shared by each atom. All right. Now, moving on to the covalent, the physical properties. One thing you must understand is that the forces of attraction, they are very weak. They are very weak intermolecular forces of attraction, also known as, for example, this C double bond O, right? These forces are very weak. They have a name, this Van der Waals forces. Okay, you don't need, this is more for a higher level, but yeah, they are very weak forces of attraction. And so because of that, if you watch the video on the ionic bonds, you would realize that if you have weak forces of attraction, weak forces, this leads to less energy required to break the force, which leads to low melting point and boiling point. Okay, so that's the reason why covalent compounds have got low melting point and boiling point. Also, they are not able to conduct electricity. Cannot conduct electricity. Why? Because a covalent compound does not have any free and mobile ions or electrons. All the electrons are being bonded, they are being used in the bonding. So they don't have any free or mobile electrons and ions. Okay, covalent compounds, point number 3, they are generally soluble in organic compounds, but not in water. So this is opposite to what you would see in the ionic substances. The ionic substances are generally soluble in water but not in organic compounds. Covalent substances is different. Okay, now I want to move on to how the covalent compounds are sometimes being arranged. So you have two types of uh, uh, covalent substances, right? You've got simple covalent and you've got giant molecular. Okay, so an example of a simple covalent would be carbon, CO2, water, and chlorine gas and everything, O2 and whatnot. Okay, examples of giant molecular, you have diamond, graphite, you have silicon dioxide. Okay, all these are examples of giant molecular substances. Now, what is a giant molecular substance? It is basically being formed by a large number of atoms that are covalently bonded to one another. For example, if I look at a diamond, all right, you've got one carbon atom, and then which is bonded to here, bonded to another three. Each carbon atom needs 4 bonds. Okay, so here you have another one bonded to another 3. So it will go on, right? It will keep going on and on and on. And here you see this is a giant molecular structure. So because there are so many bonds and everything, a large amount of energy is needed to break these bonds, and that's why this kind of giant molecular substances, they have got high melting point and boiling point. For simple covalent, we already explained to you why, because not a lot of energy is required to break their bonds. Okay, it is also very strong and hard, like for diamond especially, is very strong and is very hard because of this structure over here. All right, for if you want to understand a bit more about diamond, it cannot conduct any electricity because it does not have any free moving ions or electrons. I'll explain a bit more about diamond and graphite in right now. So you know that they are both giant molecular substances, right? So for diamond, I already showed you just now how the electrons are being arranged, how the atoms are being arranged. So it's this way, right? Okay, it's not very clear, but yeah, I hope you get the picture. For graphite, it's slightly different. For graphite, it's layers that are kind of together. So these circles are your carbon atoms, and you see that layers of carbon atoms, and then there's another, this is one layer, right? There's another layer here, and then there's another layer here. Okay, so layers of carbon atoms are kind of over one another. It contains layers of planes which contains the carbon atoms. Now each carbon atom is connected to 3 other carbon atoms, 1, 2, and then there will be another one over here. Now because of this, there are some free electrons, because you realize that carbon atoms are supposed to be connected to 4, right? But there's only 3, so there are free electrons, and because there are free electrons, they can now conduct electricity because of the free electrons. And because they can, you see these are layers, right? And the layers can slide over each other very easily. It is very soft and it's very slippery. So that is why graphite is soft and slippery, but diamond is hard and rigid because you cannot actually break it very easily. So that's covalent compounds. Again, I hope you understand now. If you are the part about the graphite and the giant molecular substances, that's a bit more advanced level, so you might not be studying it, but it's good for you to know. So I hope you understood, and again, if you have any questions, just comment below and we will try and help you out. Thank you. Bye bye.